After about 3 semi-successful videos on my course, Quantum Mechanics for the Working Professional, I decided to pull the plug on the current approach. The original goal that I had in creating the course was to introduce quantum mechanics to folks who hadn't gone through an undergraduate program in physics specifically. But perhaps they managed to see some calculus or linear algebra or something. You know, maybe they were economics majors or engineering majors, computer science types, or even just developers, folks that have some familiarity with math. Like Sakurai, I wanted to introduce the ideas of quantum mechanics through the idea of spin, because finite dimensional vector spaces just felt much more approachable than, say, function spaces that you would normally encounter when, say, studying the infinite square wave potential or things like that. Besides, the application of spin-a-half physics to quantum computing is pretty much obvious. Anyway, my regret was simple. I could not help but get caught in the weeds. That's actually how all of this started, or stopped, if you like. I was not able to finish to my satisfaction the 4th lecture in this video. It just kept going on and on and on with revision after revision after revision. The reason why I chose to start with spin-half physics is I wanted people to get involved with doing computations right off the bat, right away, and to get comfortable with it so that they could move forward with an understanding of quantum mechanics wrapped in the mathematics. Why? Because shut up and calculate is really truly the best way to learn what is going on. I mean, after all, you can ponder ontologically equivalent formulation like Everett's many world hypotheses, like after the fact. Indeed, if you cannot verify that the formulations are observationally equivalent, then what, from a scientific perspective anyway, is the point of teaching them? I wasn't able to do this well, at least in my opinion, in a way that was able to communicate the physics clearly. It was too weedy, and it got too weedy too quickly, at least with the mathematics. Also, I had an operational problem. I simply could not keep up with the videos in any sort of regular way. Worse, the introductions to those videos, the ones that I'll link it below, where I talk slowly and methodically and walk into the light and so on, just didn't feel true to my own personal sense of discussion at all. I'm way too animated. So I shut it down. Failure acknowledged, course correction deployed. So I'm creating a series of videos now that will be less formal, and I'm going to start with more familiar, more qualitative material. I'm starting with a hydrogen atom, and I'm doing this for a number of reasons. First, most folks who want to study quantum mechanics, who want to study this kind of stuff, have had some high school chemistry already. The qualitative properties of electrons and orbitals around hydrogen atoms, SPDF, that kind of thing is already familiar to most people in this position. And I can build from that. I can build from that knowledge, and that will actually help the students out. The whole idea of electron orbitals and electron clouds is intimately related to how quantum mechanics works. Second, the kind of blog vlog style of lecturing affords a lot better operational stability, at least for me. I can always aggregate the material, things I've been working on, into playlists and curated short lists and so on after the fact. And finally, and this is an important one to me, by approaching this from a more qualitative perspective, I can also include problems that are at different levels of difficulty that folks can try out depending upon what their interests are and how engaged they are. For example, we can do integrals right off the bat in the problem and solution sessions for folks that are interested in that. But if you're not, no big deal. So in other words, I can engage more folks more completely and talk to a broader spectrum of interested parties. Since by assumption, anyway, the folks interested in studying quantum mechanics and quantum computing are a diverse lot these days. Anyway, I have just released the very first lecture notes in this series on my website. It's not quite listed yet, but I'll link to it in the show notes, and there should be a link somewhere in the news section. But anyway, thanks for your patience, but let's get after it.